To graph this one, we again identify where our asymptote is. Our asymptote is that K value, which is that 11. So at 11, I would draw my horizontal line. Remember, it's dashed, and I have to draw it because my calculator cannot. So the equation of my asymptote, because it's horizontal and at 11, I would say is y equals 11. Now I go ahead and I take my calculator and I enter this into my calculator so that way I can get some points to graph it. So I would have -2 times 3, and then make your exponent that x plus 1. If you have an older calculator, make sure you put that x plus 1 inside parentheses, and then plus 11. Look at your table to graph your points. Make sure that you are identifying points that you can graph. If you cannot graph them, then make sure that you are scrolling to where you can find some. So we're going to have to scroll down here. Until we find some that we can graph. So right here, we can graph that -2, 10.33, because again, that's not too terrible. -1, 9, 0, 5, 1, -7, and then everything else gets a little bit too big. So let's go ahead and graph those. So we'll go -2, 10.33, -1, 9, 0, 5, 1, -7. Now again, I want to make sure that my dots look like how they're supposed to. So I'm going to look back at my calculator, look at the graph, and I need to make sure that I connect my dots to where it looks like what I have on my graph. Now if we look at this, it looks like the graph just kind of stops right here. However, you have to think about where your asymptote is. My asymptote is at 11. My window stops at 10. So if I really want to see how big this gets, I need to change my window max to where it ends up being that 11. So I can actually see what my graph does at a y value of 11. Now that I change that, I look back at my graph and I can actually see that the graph does follow my asymptote. It doesn't just stop. It does follow my asymptote. So I need to make sure that I graph it to where it is following my asymptote. Make sure that we draw arrows at the ends. Because this is an exponential, all exponentials have a domain of -infinity to infinity. My range is flipped backwards, so the asymptote is as tall as it gets. That's the highest it gets. So my range for this instance would be -infinity up to 11, both inside parentheses. Now let's analyze this graph a little more. This graph would be considered a growth graph. And this graph is a growth graph because my b value is bigger than 1. My b value is bigger than 1. And anytime my b value is bigger than 1, that means that it is a growth graph. This one is kind of hard to see because the a value being a negative does flip it down. But because my b value is 3 and 3 is bigger than 1, it is a growth graph.